compute the equivalent resistance of the network in the figure. The battery has a negligible internal resistance. Find the current throughout this, current throughout this, and throughout this. Now I did this assignment correctly, but I did overcomplicate something. This could be done a bit easier. Doesn't matter. So let us see. Internal resistance is 0. In that case, calculation is simpler, but I did not take that into account. Does not matter. Let us see what I did 5 years ago. And a little bit more. So this is the same thing. You see here, there is through this one current E1 through this conductor, and at this point A, that current will split in two. One will go through this resistors, and another will go through this resistors here. And that you could find by googling Kirchhoff current laws. This is 1 ohm, this is 3 ohms, 5 ohms, and 7 ohms. Okay, now this current is separated into these two, or for this point here, number of currents that goes in, and the strength of the current that comes in, it will be equal to the one that comes out, or sum of all currents for every point will be 0 always. So this current will divide these two. And other important thing is that these points A and B are at 1 voltage. So voltage between these 2 points and voltage between these 2 points is the same, and that is voltage between those 2 points. And because there is no internal resistance here, that will be this voltage, but we'll do something differently. Okay, first of all, we will find equivalent resistance for this construction here. This is 1 ohm, 1 ohm plus 3 ohms. This is 7 ohms and 5 ohms. So equivalent for this thing here when you just add them together. So that is that. And equivalent for this thing here is when you just add them together, and that is this thing here. That is resistors in series, but this and this is parallel, and because of this, this will calculate as this. So this thing here and this thing here is in parallel connection. So this is how you calculate resistance for parallel connected resistors. And from here you will get 1 divided by 4 ohms and 1 divided by 12 ohms. And from there, that is 1 divided by 3 ohms. Why? You see, you have to multiply this thing by 3. So upward you will have 3 and downward will be 12. And when you add those two things together, downward will be 12 and upward will be 3 plus 1 is 4. So 4 divided by 12 is the same as 1 divided by 3. And that is that. Now you flip this, and you get that equivalent resistance for all of this construction is 3 ohm. That is what it is. So for the Ohm's law for the entire circuit, when you don't have an internal resistance, this is the source of the voltage, and this is the equivalent resistance, and this is the current E1. That current that goes throughout this source. And from here, we did find the current E1, that is 16 amperes. So current from here that moves from here is 16 amperes. It's the same current here is also 16 amperes. But E2 and E3, when you add those two together, you will get what? You will get 16 amperes. Okay? So we have next thing. E1 is equal E2 plus E3. Of course it is. And this is the Ohm's law for the part of the circuit. And what is this thing here? Voltage between points A and B is 1 ohm plus 3 ohms times E2. This is the Ohm's law for the part of the circuit, and actually for this upper part of the circuit. Voltage between these two points is E2 times this resistance. And this resistance is 4 ohm. Similarly, voltage between points A and B is this resistance times this current. So it's the same voltage, but E3 times this resistance is voltage between those 2 points. And we have this thing here. Voltage, this voltage and this voltage is identical thing. So on the left side you have 4 ohms times E2. On the right side you will have 12 ohms times E3. Then you divide by ohm. And after that you divide by 4. And you have that is E2 is equal to 3E. E2 is equal to 3E. And we have that E1 is equal to E2 plus E3. And as you can see, E2 is this much. So E1 is 4 times E3. This is not E. You do not call this E, doesn't matter. So 16 amperes is 4 I3. And from here, I3 is 4 amperes when you divide this by 4. This is I3, and I2 is 3 times as much. And that is 12 amperes. So current is E3 is 4 amperes, current E2 is 12 amperes. So when I calculate it, there is really little to do from this point on, and you could do it yourself, or for complete literal answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. There is an easier way to do this, but I did this as I did. So that's all there is to it. Thank you. Bye.